There's something that happens to NAD+ levels as we age that's so consistent and so profound that many researchers consider it one of the fundamental mechanisms of aging itself. NAD+ levels decline with age in virtually every tissue that's been examined, including the brain. By the time you're in your 60s or 70s, your NAD+ levels might be 40 to 50% lower than they were in your 20s. This isn't a disease. This is normal aging. But it has consequences. When NAD+ declines, all the processes that depend on it become less efficient. Energy production decreases. DNA repair slows down. Sirtuins, those longevity-associated proteins, have less NAD+ to work with. Mitochondrial function deteriorates. Inflammation increases partly because cells can't maintain proper metabolic balance. This creates what some researchers call a downward spiral of aging, where declining NAD+ impairs cellular function, which creates more stress, which depletes NAD+ further. Why does NAD+ decline with age? Multiple reasons. NAD+ synthesis appears to become less efficient. The enzymes that make NAD+ work less effectively. At the same time, NAD+ degradation increases. Remember CD38, that NAD+ consuming enzyme activated by inflammation? Its activity increases with age. So you're making less NAD+ and breaking down more of it simultaneously. It's a perfect storm for NAD+ depletion. This age-related NAD+ decline is why dietary strategies to support NAD+ become more important as we get older, not less. A 25-year-old with robust NAD+ synthesis and low degradation can probably maintain healthy levels with a mediocre diet. A 75-year-old with declining synthesis and increased degradation needs to be more intentional about providing the nutritional building blocks for NAD+ production and reducing the factors that drain it. What does this mean practically? It means older adults should prioritize protein intake to ensure adequate tryptophan for NAD+ synthesis. Remember, many older adults are protein deficient, often without realizing it. It means including regular sources of vitamin B3 from foods like poultry, fish, nuts, and mushrooms. It means managing blood sugar carefully because glucose dysregulation, which becomes more common with age, puts additional stress on NAD+ metabolism. It also means paying attention to inflammation and oxidative stress, which drain NAD+ and become more problematic with age. This circles back to all the dietary factors we've discussed: antioxidant-rich foods, anti-inflammatory fats like omega-3s, polyphenol-rich plant foods. An aging diet should be a comprehensive metabolic support strategy, not just focused on NAD+ in isolation. But let's acknowledge the elephant in the room. Even with optimal nutrition, we cannot fully prevent age-related NAD+ decline through diet alone. The decline is driven by changes in enzyme expression, cellular damage, and systemic aging processes that food cannot completely override. Nutritional support can probably slow the decline and maintain somewhat higher levels than would otherwise occur, but it cannot stop aging. This is where supplement companies often overreach. They sell NAD+ precursors with promises that suggest you can turn back the clock on aging, restore youthful NAD+ levels, and prevent all age-related diseases. The reality is much more modest. Supplements might raise NAD+ levels somewhat, though how much they raise it specifically in the brain remains unclear, and whether raising NAD+ translates to meaningful health benefits in humans is still being studied. The food-based approach to NAD+ support in aging is more conservative but probably more sustainable. It's about providing consistent nutritional support over years and decades, maintaining the healthiest NAD+ balance your aging body can achieve, rather than trying to artificially force levels back to youthful ranges. It's working with your biology, not against it. There's also something to be said for the other nutrients that come along with NAD+ supporting foods. When you eat salmon for omega-3s and protein, you're also getting vitamin D, selenium, and other nutrients. When you eat leafy greens for antioxidants, you're also getting folate, vitamin K, and fiber. This comprehensive nutritional package is probably more valuable than NAD+ support alone could ever be. The aging brain needs all the support it can get. Declining NAD+ is one challenge among many, including reduced blood flow, increased inflammation, accumulated cellular damage, and mitochondrial dysfunction. A diet that addresses NAD+ as part of a broader metabolic support strategy makes more sense than obsessing over NAD+ to the exclusion of everything else. Aging is complex. Our nutritional response to it should be equally sophisticated.